Okay, welcome to part 2 of Systems of Equations, where we're going to do a little bit more with the systems of equations that we just learned how to solve in part 1. But first, we're going to take a little bit of a detour with our do now and our first question. Not with the do now, I'm sorry, with our first question. So let's go ahead and do this do now just to remind ourselves how to do this. Pause the video, solve it, and come right back. I will wait a couple of seconds and then I'll keep going. Okay, once again, we see that in this system of equations, y is equal to this, and y is equal to this. And what we want to know is when are both of these statements true at the same time? That is, what x value and what y value makes both statements true? Well, what we're going to do is we are going to pull over this green equation. This goes 3x minus 1. And we're going to set it equal to this blue one because they both equal y, so they both equal each other at the point where they're the same. 2x plus 9. Okay. Now what I'm going to do, I'm going to take this arrow out of my way because we'll need that space. I'm going to set these equal to each other, and I'm going to solve. Once again, I'm going to try to get rid of the smaller one. So that negative 2x, we're going to do plus 2x on both sides. That's 0. 3x plus 2x is 5x, so 5x minus 1 is equal to 9. Now we get x by itself, plus 1, 5x equals 10. And I can see by sight that that's going to be 2. But you could also do this. You could do 5x divided by 5, 10 divided by 5. These 5s will equal 1 and just fall out. X equals 10 divided by 2, 10 divided by 5, which is 2. I'm not done, however, because I still need to take one of the equations from the beginning. 3x minus 1 looks like the one that's easier, so I'll use that. Y equals 3x minus 1. And I'm going to plug in this x equals 2 where x is. So if x equals 2, what does the rest of it become? Y equals 3 times 2 minus 1. So y equals 6 minus 1. So y equals 5. And I have found my x, I have found my y, and so my solution is 2, 5. Easy peasy. Now we're going to go on and do something just a little bit different, but it's similar to the stuff that we have been doing in the way that it works, just not the way it looks. Okay? So this one here is asking me to solve for w. What this is here is the formula for area of a rectangle. Area is equal to the length times the width. But what we can do with formulas is we have free range to manipulate them, and the way we do it is like this. We say, well, what do I want by itself? I want w. The word solve means get w by itself. Okay? So what I have is I start with area equals length times width, and then I divide by L, and I divide by L. Look what happens when I do that. L divided by L is just 1, and so what's left over here is w. W is equal to A divided by L. Okay? So that is my answer to my, or that is how I solve for w. This means if I was given, for a rectangle, if I was given the length and the area, I could then tell immediately what w was by just taking the area and dividing by the length. This is a skill that we will need to use from time to time, and especially in this lesson. So let's do a couple others. Number 2 says to solve for h. So what I want to do is I want to get everything away from the h. Well, the way I get rid of 1/2 is I can do a couple of things. I can divide by 1/2, but that's really the same thing as multiplying by 2, because look what happens when I multiply by 2. The 2 and the 2 will cross cancel. They both become 1s. And I don't have to worry about fractions anymore because that 1/2 and the 2 canceled out. However, when I multiply one side by 2, I have to multiply the other side by 2, and then I will rewrite my equation. So I get 2a is equal to bh. Well, I'm not done yet because I want to know what h is. And so what I will do, I will divide by b on both sides, and that will get rid of everything but h. So I am left with this expression here, which is what I was looking for. And I'll rewrite that just so it's a little less sloppy. H equals 2a divided by b. We're done. Fantastic, no? Very easy for what we've been doing, I think. I did not actually remember to write what to solve for this, so let's do it right now. For this one, I want to solve for L. Okay, so I want L by itself there. And so the first thing I'm going to do is I'm going to see, well, I can't do anything with the L first because I've got this 2w term in the way. And so what I'm going to do is I'm going to get rid of that 2w term from both sides. Now over here, 2w minus 2w, those are like terms, so I can just subtract and I get 0. But on the other side, p minus 2w, those are not like terms, so I can't do anything else. It's just p minus 2w, and that's going to equal 2l. I have only one step left now, and that is to get L by itself, so I divide by 2. I divide everything on the other side by 2, because that's the way it works. When you divide one side of an equal sign by 2, you divide everything on the other side of the equal sign by 2. And I have L is equal to p minus 2w divided by 2. Okay? Another way to write this is you can say L is equal to p over 2 minus 2w over 2. And the reason you might do that is because those 2's would cancel out. You could also say L is equal to p over 2 minus w. Either answer would work. This one or this one, they both mean the same thing, and both are solved for L. Okay? And finally, this one's pretty self-explanatory. We want to solve for S. S is almost by itself, but we have A equals S squared. And so the way to undo that square is to take the square root of both sides. The square root and the square will cancel each other out, so I get S equals the square root of A. And that is my answer. So if I was given the area, this is the formula for area of a square, by the way. All of these are formulas you know. This is the formula for area of a square. I can just divide, or I can, not divide, I'm sorry, take the square root of the area, and I know what my side length is for a square. Okay, here are two for you to try right now. You might have to go back and watch that section again, but I want you to rearrange the formula for the perimeter of a square to solve for S. That means get S by itself. And rearrange the formula for the volume of a rectangular prism in order to solve for W. I want W by itself. Okay? These are both very, very simple, but you need to know how to do them. Okay, now what we are going to do, the reason we were rearranging those equations is because that's what's coming up right now. We need to solve the system of equations right here. However, if you are incredibly clever, you might notice that these are not the same kind of systems of equations as what we were doing last video. The reason for that is it's not in this form, y equals 2x plus 3, y equals 5x minus 2. Okay? Notice, this was a question like we had last time, where both sides had y by itself already. Notice we don't have y by itself anymore. So that's what we kind of want to do. But it doesn't have to be y. We just need one of the variables by themselves. So what I first have to do is I have to add a third step. Now what step 1 is get one of the variables by itself. And let's look at this helpful hint over here in the box. We can rearrange our equations to isolate either variable. Okay? We can either get y by itself or get x by itself. Okay? And what we really want to do is we want to isolate the variable that has a coefficient of 1. That means find one of the variables, in this case it's x, that really has a 1 in front of it, or it won't be written at all. But that's going to be the one to get by itself because it'll save you a step. So what we're going to do is we're going to get both sides so that x is by itself. And once you understand what we're doing, the work's actually pretty easy. We want x by itself, so what we're going to do is we are just going to add y to both sides. And look what I have here. These y's will cancel out because they add up to 0. X is equal to y plus 3. Look what I have on the other side when I do this. I have x plus 5y equals 39. I'm going to subtract 5y from both sides. What do you wind up with? Well, those add up to 0, so they cancel out. X equals negative 5y. Let me undo that so it doesn't look like a division sign. X equals negative 5y plus 39. Or 39 minus 5y. Either way would have worked. They both mean the same thing. Once I have that, now I have something that looks like a system of equations. X equals y plus 3. X equals negative 5y plus 39. Because these are both equal to each other, because these are both equal to the same thing, they're both equal to x, I can say that y plus 3 and negative 5y plus 39 must be equal to each other as well, because they're both equal to x. So to solve this, I will do y plus 3 equals negative 5y plus 39. And then it's just a simple matter of solving like we've been doing over and over and over again. We don't want variables on both sides, so we get rid of the smaller one. In this case, it's negative 5 is smaller than 1. So plus 5y plus 5y. These add up to 0. I am left with 6y plus 3 equals 39. I will subtract 3 from both sides. I am left with 6y equals 36. I will give myself some more space. And I will divide both by 6. Divide by 6, divide by 6. Those 6's equal 1, so 1y, or just y, is equal to 36 divided by 6, so y is equal to 6. Okay? I'm not done, though, because I've only found y. I still want to find x. So what I'm going to do is the same thing we've been doing. I'll keep it over to the side here. But what I want to do is I want to find the simpler equation. There's no doubt in my mind that it's this one here. X equals y plus 3. I will take that equation, x equals y plus 3, and I will figure out what x is because I already now know what y is. Y is 6, so it's going to go right there. 6, so x equals 6 plus 3, x equals 9. I am done. What I'm going to do is write it in coordinate notation, 9, 6. There's my answer. And I have solved. Okay? That was solved for the remaining variable, by the way. I should have written all of this over here. I apologize for not doing that, but that's what we're doing. We solve for the remaining variable. So really the only difference when we do not have our equations in this form right here, when I don't start off with my equations in this form right here, the only difference is I have to get them both solved for a single variable. Okay? In this case, we chose x because remember, x here had a coefficient of 1. X here had a coefficient of 1, and so I knew it would be a little bit easier to get that by itself. I could have gotten y by itself instead, but I would have had an extra step each time. Okay, let's try one more. I want to solve the following system of equations. Again, I do not have a variable by itself in both of them. This time, however, my work's a little bit easier, because look what happens when I write each one of these out. Y equals 5x minus 2. 6x plus 3y equals 15. And what's going to happen is this one's already done. Y is already by itself. So I know over here, I'm definitely solving for 3y. Or I'm sorry, I'm definitely solving for y. Because that means I only have to rearrange this equation here and not both of them, because the other one, you already have y by itself. Yay! Okay, so to get y by itself, I first need to get everything else away from it. First thing I do is subtract 6x from both sides. Now, this crosses out over here, but it doesn't, there are no like terms on the side with the 15, so I am just left with 3y equals negative 6x plus 15. Or 15 minus 6x. Either way you'd like to do it is fine. I usually just write the variable first. I'm not done though. I have to get y by itself. There's still this 3, so I have to divide by 3. And then here's the tricky part. Okay? Pay very, very close attention to this part right here. When I divide this side by 3, I have to divide everything over here also by 3. So I will be dividing the negative 6x and the 15 by 3. The nice thing is, though, this is like saying y equals negative 6x over 3 plus 15 over 3, and both of these are going to simplify. This 3 becomes a 1, this negative 6 becomes a negative 2. This 3 becomes a 1, this 15 becomes a 5. And so look what I have here. I have y equals negative 2x plus 5. Now I have a system of equations that looks like it's in good form the way I like it. So I'm going to write them down here. Y equals, y equals, let's see what that was again, 5x minus 2. And y equals negative 2x plus 5. All I'm going to do now is set these equal to each other because they are now both equal to the same thing, this y, so they're clearly equal to each other. So I get that 5x minus 2 is equal to negative 2x plus 5. Okay, now I want x's to only one side, so I will add 2x to both sides. Those cross out. I get 7x minus 2 equals 5. Almost done getting x by itself. 2 more steps, but they're easy. Plus 2 plus 2. 7x equals 7. I can see the answer already, but if you can't, divide by 7. Divide by 7. 7 divided by 7, x equals 1. One more step left, and that is to find the easier of these two equations. There's equation 1, equation 2, and solve for the remaining variable. Well, equation 1 looks just a little bit easier, so I'm going to use that. Y equals 5x minus 2. And I know what x is, so I'm going to plug it in. X is 1, so that goes in right here. And we get y is equal to 5 times 1 minus 2. Okay, so that means y equals 5 minus 2, and so y equals 3. I have an x, I have a y, I am in fact done. 1 comma 3, and I have my answer. Let's see if there's anything else we have. Now, this one is your turn. You're going to solve the following equation. Notice anything that is not already solved for a variable, you will have to solve for a variable. And I will give you a hint that the answer is 4 comma 3. So that is what you should get when you finish doing this question on your own. That is all for the lesson, it appears. Yeah, because that's already done. Well, that was easy. Okay, I invite you to go back, if you have to, and rewatch any of this video. And if you still need help, what you're going to want to do is Google solving systems of equations. There you will find immediately about 10,000 pages that will help you do this. Okay, some of them will be easier to understand than others. But you need to be able to do this question that's on the screen right now before you come to class next time. Okay? Have a nice weekend, everybody, and I will see you on Monday.